Hi everyone! Today we'll be looking at exterior angles of triangles. Here's the FLT for this lesson. Given properties of exterior angles of triangles, I will be able to find missing angle measures. In the last video, we talked about interior angles. Today we'll be talking about exterior angles. So let's look at a definition first. An exterior angle is an angle formed by one side of a polygon and the extension of an adjacent side. So in a triangle, this would be an exterior angle. Notice how one of the sides is extended, and we look at the angle that's created basically by that extension. And then a remote interior angle is an interior angle that is not adjacent to the exterior angle. And adjacent basically just means next to. So these are angles that are not next to the exterior angle. So for this triangle, these two angles are remote interior angles. So let's look at the relationship between the exterior angle and its remote interior angles. Here I have a triangle with one side extended, and I have four angles: angle 1, angle 2, angle 3, and angle 4. Angle 4 is my exterior angle, and angle 1 and angle 2 are my remote interior angles. So let's write out some things that we already know. So I know that the sum of the interior angles of a triangle is 180 degrees. So the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 equals 180 degrees. Here I'm using the idea of interior angles. And I also noticed that I have supplementary angles here. Angle 3 and angle 4 are supplementary, which means that they add to 180 degrees. So the measure of angle 3 plus the measure of angle 4 equals 180 degrees. And we're using the idea that these angles are supplementary to each other. And I'm going to add some color so that we can easily distinguish between the angles. We have the measure of angle 3, so we're talking about this angle right here. Angle 1 is a remote interior angle, as well as angle 2. And angle 4 is the exterior angle. And do you notice anything right here? Do you see a relationship between the remote interior angles and the exterior angle? Alright, so I rewrote it because I needed more space. These are the two equations we found. Notice how they both equal 180 degrees. So that means we can set the left sides equal to each other. So that's what I'm writing right here. And here we use the idea of the substitution property of equality because both equations originally equal 180 degrees. Now let's subtract the measure of angle 3 from both sides. Notice how this is a common angle on both sides of the equation. So we can cancel them out, and we're left with the measure of angle 1 plus the measure of angle 2 equaling the measure of angle 4. But what exactly does this mean? Let's go back to the other screen. So we just found out that the measure of angle 1 plus the measure of angle 2 equals the measure of angle 4. So let me rewrite that over here. And then we think about, what do these measures represent? So the left side, this represents the sum of the remote interior angles. And the right side, this represents the exterior angle. So we have derived that the sum of the remote interior angles equals the exterior angle measure. And this is actually called the exterior angle theorem. The measure of an exterior angle of a triangle is equal to the sum of its remote interior angles. So here's the triangle that we looked at from earlier. And the measure of angle 4 equals the measure of angle 1 plus the measure of angle 2. So the measure of the exterior angle equals the sum of its remote interior angles. So we're going to use this exterior angle theorem to solve for some examples. Here's our first example. It asks us to find the value of x. We're given the exterior angle, and here are the two remote interior angles. I know by the exterior angle theorem that x degrees plus 54 degrees equals 78 degrees. And to solve for x, I subtract both sides by 54 degrees. I'm left with x equals 78 minus 54 is 24 degrees. So I was able to solve for x using the idea of the exterior angle theorem. Here's another example. Again, we are asked to find the value of x. So go ahead and try labeling the exterior angle and the remote interior angles on your own, and then press play when you're ready. So this is our exterior angle, and here are the two remote interior angles. So by the exterior angle theorem, I know that the sum of the two remote interior angles, so 2x degrees plus 5x minus 2 degrees, equals 145 degrees, the measure of the exterior angle. Let's combine like terms. We get 7x minus 2 degrees equals 145 degrees. Let's add 2 on both sides. So we're adding 2 degrees on both sides. Cancels out. We have 7x degrees equals 147 degrees. Almost there, divide both sides by 7, and we get that x equals 21. We were able to solve for x by using the exterior angle theorem. For example 3, notice how we're not actually given the diagram of a triangle. And this is what some of your Delta math problems would look like. So let's work through this together. So the example tells us, in triangle PQR, side PR is extended through point R to point S. And also, the measure of angle QRS equals 7x plus 8 degrees, and the measure of angle RPQ equals 20 degrees, and the measure of angle PQR equals 44 degrees. And we are going to solve for x. So our first step here is to draw out what is described in the problem. So here's triangle PQ, R, and PR, the side PR, is extended to point S. And let's label the angles we do know. So I know that the measure of angle QRS is 7x plus 8 degrees, my exterior angle. And then my measure of angle RPQ is 20 degrees. The measure of angle PQR is 44 degrees. So I've set up this triangle, and I'm going to add some color just so it's a little easier to see. So we have the exterior angle, and then its two remote interior angles. So I know that the measure of the exterior angle, so 7x plus 8 degrees, is equal to the sum of the interior angles, 20 degrees plus 44 degrees. So again, the exterior angle theorem tells us that the measure of the exterior angle equals the sum of its remote interior angles. And let's simplify. 20 plus 44 is 64 degrees. And subtract by 8 on both sides. And we're left with 7x degrees equaling 56 degrees. Divide both sides by 7. And we've solved for x. X equals 8. So we solve for x using the exterior angle theorem. The most important step, honestly, for these types of problems is to correctly set up your triangle and correctly label your given angles. Here's our last example for the day. Again, it's the type of example where you have to draw your own triangle. So in triangle NOP, side NP is extended through point P to point Q. The measure of angle PNO equals x plus 14 degrees. The measure of angle OPQ equals 5x minus 2 degrees. And the measure of angle NOP equals x minus 1 degrees. And we are asked to find the measure of angle OPQ. Let's start off by drawing the triangle. So here's the triangle. Let's label it NOP. And side NP is extended to a point Q. So here's our basic setup. Now let's label each angle. So the measure of angle PNO, this one right here, is x plus 14 degrees. The measure of angle OPQ, that's the exterior angle, right here, is 5x minus 2 degrees. And lastly, the measure of angle NOP is x minus 1 degrees. So we've identified the three angles. This first one right here, x plus 14 degrees, that's a remote interior angle. And then we also have the exterior angle measure given to us, 5x minus 2 degrees. And lastly, angle NOP is another remote interior angle. So from here, let's set up an equation. We know that the sum of the remote interior angles, so x plus 14 degrees plus x minus 1 degrees, equals the measure of the exterior angle, 5x minus 2 degrees. And then from here, let's combine like terms. X plus x is 2x, 14 minus 1 is 13 degrees equals 5x minus 2 degrees. I'm going to start off by subtracting 13 on both sides. and we're left with 2x degrees equals 5x minus 15 degrees. And next, I want to move the x over from the right side to the left side. So we subtract both sides by 5x. We're left with negative 3x degrees equals negative 15 degrees. Let's divide both sides by negative 3. And x equals 5. But we're not exactly done yet because the example asks us to find the measure of angle OPQ. So we're going to use the fact that x equals 5 to find that angle measure. So we just found that x equals 5, and we know that the measure of angle OPQ is 5x minus 2 degrees. But let's replace the x with the 5, so 5 times 5 minus 2 degrees. 5 times 5 is 25, minus 2. 25 minus 2 is 23. So the measure of angle OPQ is 23 degrees. We were able to find this missing angle measure using the exterior angle theorem to solve for x and then plugging it in. So today we talked about exterior angles, and we learned that the measure of an exterior angle of a triangle is equal to the sum of the measures of its remote interior angles. Great work today, and please remember to submit your notes on Canvas. Thank you.